Hello, welcome. Let's try to solve another Leetcode problem 742, closest leaf in a binary tree. So for this problem, we are given the root of the binary tree where every node has a unique value. And this is also very important because we need to use this kind of unique value. Yeah. And we are also giving a target integer k, so we're going to return the value of the nearest leaf node to the target k in the tree. Yeah, let's also try to understand what is the meaning. What is the nearest leaf node? So the nearest to a leaf means the least number of edges traveled on the binary tree to reach any leaf of the tree. Also, a node is called a leaf if it has no children. So definitely we understand the last sentence. So what about this one? Nearest to a leaf means the least number of edges and traveled on the binary tree to reach any leaf of the tree. So let's just use an example. Maybe we're going to understand it. So for this tree, we are giving a value k. It means this node. So what is going to be the nearest leaf? It's going to be 3 and 2 because the path from 1 to 3 it is 1, from 1 to 2 it is 1. And we can return either of them, so we're going to return a 2 or 3, it doesn't matter. And for the second example, because we only have one node, it is the root node 1 and k equal to 1, it is this node. Yeah, and it is also a leaf by itself, so we're going to just return this leaf node. It's going to be a 1. Yeah. Because our final return is going to be an integer, so it's going to be value 1. And let's just check the third example. Maybe this is a better example. So I'm going to use this example to explain the problem. So now we are giving this value k equal to 2. It is this node. So we are going to get the closest node, which is the distance to this node 2. So this 6 is a leaf node and 3 is a leaf node. So 6 to 2, the distance is going to be 3. And 3 to 2, the distance is going to be 1 plus 1, it's going to be 2. So we're going to return the closest distance, it's going to be this node 3, but we're going to return the value instead of the node. Yeah. Now if we understand the problem, maybe this is going to be a good problem. I'm not sure if you solved such kind of problem or not, but definitely we cannot solve it immediately by using the tree traversal or tree level traversal. At least I don't think about that immediately. So my idea is that we are giving a tree, so why not we turn this tree into a graph? Because if we turn this tree into a graph, definitely it's going to be the BFS. We can solve the problem because it's going to be the shortest path in a graph. Yeah. And how can we turn this graph? And this is also easy. Because we are given the tree, and we can just connect them together and make it an undirected graph, and it will be like this. Yeah, and later on in my coding, I'm gonna explain how to make it, but definitely this is easy. So after we turn this into a graph, and our second step is that we need to find this node. Definitely it is this value, k equal to 2. But in our graph, we need to put the node instead of the value, because if we put the value inside, how should we know this 6 is a leaf node? This 3 is also a leaf node. We don't know about it. So what we're gonna do is that we just need to put the node inside the graph instead of the value. Because if we put the node inside, we can use the node dot we can use this node dot left and node dot right. Yeah, because definitely if we put the node inside the graph, and its node, it is also a tree node. If it is a tree node, we have the property of node dot left and node dot right. Yeah, so we can check if not node dot left and not node dot right, it means we don't have a left or right. Definitely this is a leaf node. And we can check the distance. Actually, we don't need to check the distance. We only need to return the closest distance by using the BFS in a graph. So definitely it's going to be the closest distance. If we find a node, it is a leaf node, so we just return this node first, because this node 6 will be the next layer for the graph of BFS. So this is graph of BFS. It is by layer, and from the shortest distance to the longest distance. Now if you understand the idea of how to solve the problem, definitely I'm going to start coding. Yeah, because the coding is going to be much interesting if you never solved such kind of problem before. Actually, it is not that difficult. First of all, I'm gonna start the tree traversal, but it's gonna be basically the BFS for our tree. As I am sure definitely there's going to be a root node, so I'm going to prepare the queue, and inside I'm going to prepare the root node. Yeah, this is according to the constraints, because at least we're going to have one node, so I want to put the root node inside the queue. And the second step is that I'm going to start the BFS for the tree. So while queue, I'm going to pop out the node, so node going to be equal to queue.pop on left. Yeah. Let's first just finish this kind of structure. So if a node dot left exists, so queue need to append node dot left. Yeah. So if node dot right exists, so queue need to append node dot right. So this is basically tree BFS structure. We don't need to prepare the visited set. We don't need to prepare anything, and only a queue is okay. But we also need to prepare the graph, as I said before. So for my graph, I'm going to prepare a default dict, and inside it's going to be the list. So I don't want to import it because in Leetcode it is not necessary. Everything is just imported for us. Yeah, but in other environment IDE, you have to import it. So maybe the default dict is from collectors, and the dequeue is just from the dequeue. Yeah, and it's for a long time I forget about it, but I don't want to import it from the IDE because it is not necessary. Now, for me, I want to build the graph, and from here I can build it, And if node dot left, I can build the graph. So g node dot append node dot left. As I said before, I want to put the node inside instead of the value. So g node dot left need to append node. Yeah, this is because I want to prepare an undirected graph. If I prepare a directed graph, how can I find from 2 to 6 or 6 to 2? Definitely I want to prepare an undirected graph, because if it is directed, definitely we cannot solve the problem. Yeah. Now let me just copy it for the right side. So the node need to append a node dot right, and node dot right need to append the node. Now I've already built the undirected graph. So the next step is that I'm going to use the BFS to traverse the graph. Yeah. So for the graph, I'm going to prepare a Q2. It's going to be the graph. So inside it's going to be the queue. But I need to put a node inside. So I'm going to put a start node. And where is the start node? I need to have a tag. So if this node dot value equals to k, because this k and all the values is unique. Otherwise, we cannot solve the problem. So if it is equal to k, I'm going to assign the node to the start. So the start is going to be equal to this node. Yeah. Now I want to put the start inside my queue. And as I said before, this is a undirected graph, we need a visited set. So inside the visited set, I need to put the start inside as well. Now I'm going to check the Q2. And basically it is for graph. Yeah. So while something inside the Q2, first of all, I'm going to pop it out. So node going to be equal to, this time going to be Q2 pop left. Now, as it is graph, I need to check the neighbors because I don't have left and right, and it is always about neighbors. So for neighbor in G with this node, if a neighbor not in, I'm not sure if you are familiar with such kind of a graph BFS and a tree BFS. Definitely you need to really familiar with such kind of a BFS because this is the basics. Yeah, now the weighted set needed to add the neighbor, and where is my queue? So the Q2 needed to append this neighbor, and this neighbor gonna be a node. Yeah. Yeah, I think that's all about it. Now we just need to get the final return, and we just need to check this node. If not, node dot left and not node dot right. This means it is a leaf node because this is just BFS. If we find the first node, definitely it is our final result. So we're gonna return this node, but the final return is gonna be an integer instead of the reference. So it's gonna be the node dot value. Yeah. So this is gonna be the entire code. As you can see, it may be a little bit coding, but the idea is really important. You need to turn this tree into a graph. And maybe writing this graph maybe just take you 1 minute or 2, but it doesn't matter because finally you can solve the problem, and you didn't take so much time to solve the problem. If you think about it, we can turn it into a graph. Now let me just run it to check if there's any issues. As you can see, it seems works. Now let me just submit it. Yeah, as you can see, it passed all testing cases, and I think it is pretty fast. And the time complexity is just O(n), because no matter you traverse a tree by using the BFS or traverse a graph by using the BFS, the time complexity gonna be O(n). Basically, it is the number of edges plus the number of nodes, because this is a tree problem. So if the number of nodes is n, so the number of edges is gonna be n plus 1. So n plus n plus 1 to n plus 1. So this is why the time complexity gonna be O(n), and the space complexity gonna be O(n) as well. I think that's all for it. Thank you for watching. See you next time.